We've got the mock exam practice paper for Year 11, which is to do with Unit 7. Split into two sections. First section is going to be on variables, hypothesis, and tables, and then the second section is the graph work and just reading the graph then. So in this investigation, mass will be added to the spring, and the length of the spring, the length of the stretch, will be recorded. You have access to 10 100-gram masses, and the task is to investigate the effect of the stretch of a spring as mass is added. So you can imagine I've got my clamp stand, and then I've got a spring hanging from that clamp stand, and I'm going to add 100-gram masses from that each time. So the first thing we need to do is to identify the variables. So mass will be added. So I choose how much mass. If you think about this, I can choose the mass, how many of these, but I can't tell the spring how much to stretch. Okay, so that is the thing that I change. Independent variable is going to be my mass. Remember, icy cold, independent change. The thing that I'm measuring is the distance, or the stretch really. The stretch, probably in millimeters. I've put grams there for mass because it's got there. So the thing that I measure this time is the stretch. So I'm measuring the stretch as I add those masses. So there's one mark. And then a control would be to use the same spring. If I start using different springs, the stretch is going to be different. And then the person recording the stretch, the distance, must be the same because they're going to read that ruler the same each time. Okay, so it's important you keep the same person there. State the hypothesis for this experiment. Okay, it's only worth 1 mark. So I'm going to say the more mass that I add, or the more mass that is added to the spring, the longer the stretch will be. Remember, if you put I think that before it, usually comes that sentence becomes easy then. So I think that the more mass that is added to the spring, the longer the stretch will be. So I've linked the two variables there, mass and the stretch, or the distance of the stretch. And then question 3 then, 4 marks. This is usually 4 marks. Draw a suitable results table to record your results for this investigation. So you can see that I've put my independent variable in the correct column. Goes in the first column, the thing that I changed. So I'm choosing to use 100, 200, 300, 400, 500. I've chosen that. It's in grams. So I've got my units. And then I've got at least 3 trials and a mean. And I've got an overall title or a label for that, which is distance that the spring stretches in millimeters. Okay, so that's worth 4 marks because I've included my units. I've got the variables in the right spot. I've come up with some nice, at least 5 values there that I can measure them against. So I'm okay with that. And then we go on to page 2, section 2 now. So they're going to give you, so there's different results here. It's a different study completely. So this is the volume of the water now and the time taken to boil that water. So they need to give you some new results. So the first question, circle any anomalous results. So I've looked at my data there, and I've got 30, 32, 31, that looks okay. 45, 38, 39, well 45 looks a bit high compared to them two. And look, 45 is higher than my first result on when the water was 30. So I've circled that one. These look okay, and I've identified 48 there to be anomalous. And then when I've calculated the mean, I've shown how I've done it as well. So my first line, 30 plus 32 plus 31 gives me 93. And then 3 results, because I'm going to take the 3. So I'm going to divide by 3 there, it gives me 31.0. Okay, you'll see why I put that 0.0 there now. And then, because I can't include 45, it's got to be 38 plus 39 divided by 2 then. Because I'm only using 2 results. I come up with 38.5. Because I've already gone to 1 decimal place, now I need to do the same for every one of these, which is why I got 0.0. Remember, I've got to keep my values the same. Values have got to be the same. Sorry, decimal places then. It's late at night, I'm very tired. And then calculate the mean. So I've done that. Use a grid on the next page to draw a suitable graph to represent this data. So it's going to be volume of water is continuous data, okay? And then time taken to boil seconds is also continuous data. So it's going to be a line graph. I'll show you my line graph there. So I've plotted them. So I've put my independent on the bottom. So the first column always on the bottom, and then the dependent goes on the side. I've included my units, so I've already got marks there. So that's about 2 marks because I've got units, I've got labels. I've got a nice little title up there, just in case it's worth 6 marks. So I've put it there anyway. My plotting is correct, so you can see that my scale, because they want you to use over half the paper. Now I could have done it 10, 20, 30, 40, 50, 60 like that, but it would have been a very small graph down by there. And I've had to use most of the paper. That's one of the success criteria in the mark scheme, that you use most of the paper. So you can see that I've used most of the grid there. I've gone up, so each 2 squares is worth 1. So I've taken that, so I think you can see that if I zoom in on there, that's going to be 31 there, my first result. Well, if we look back at what they've given me, it is 31, my average, and then 38.5. The 0.5s are easy to put now because I've got a whole square. So you can see now 37.5 there, and then, sorry, I'm looking at this one now. So that would be 37.5, then 38, and then 38.5 there. Okay, just using the scale correctly. So that is worth 5 marks, I think it was. Let's have a look. Yeah, 5 marks, and that's worth your 5 marks there. And then the last page says estimate how long it would take for 23 milliliters of water to boil. Well, that's easy now, because I can just grab my graph, and when it comes to 23, what have I done here? 23 milliliters there. So 23 milliliters there is going to take me up to around about, and because each square is worth 0.5, that's going to be 39.5, and I think I've written that there, 39.5. Describe the relationship between the volume of water and the time it takes to boil. Well, we've got a positive correlation there. So you can see as the volume of water goes this way, then the time it takes to boil also increases. And we can do that, we can prove that. So you can take 20 milliliters and extrapolate that back, that's around 37 seconds. And then if you take 40 milliliters, you can go up there and it's about 53 seconds. So it's going to take longer to boil with the more water you've got, it says there. Suggest 2 possible improvements for the experiments. So I've set a bigger range for the independent variable, so more volumes. So, didn't mean to do that. Let's get the results table we want really for this. So a bigger range would be, instead of just 10 to 50, maybe 10 to 100. Okay, 100 minus 10 then is going to give you that range of 90, whereas this gives you a range of 50 minus 10, which is 40. So a bigger range. And you can use smaller increments, I've said there. So instead of going 10, 20, 30, 40, 50, I could have gone 5, 10, 15, 20, 25, 30. Smaller increments is going to also improve your accuracy there. And that's that paper. Good luck in the real one.